Okay, so this is the review for the quiz 2.1 on solving linear equations, inequalities, and in general linear expressions. So this is the whole review paper if you need it again. Let's take a look at this first row of equations. Most of them I think are not too bad. So if we look at this first one, basically this is just an exercise in distributing. So we have negative 30, and distributing means to take 6 and multiply it by everything in parentheses. So it's like 6 times x and 6 times negative 3. So to solve this then, you would just add 18 to both sides. What I want to do is isolate the variable term. In other words, get the variable term by itself first. That's going to be negative 12 equals 6x. And then I'm going to divide by 6. That is isolating the variable. These things would cancel out. Negative 12 divided by 6 is negative 2. And that's the final answer. For the next one, it's just basically a double distributing in the same problem. This one is a lot like the first one. It's 5 times x, 5 times negative 8. Here, sometimes people get a little hung up on this. This minus sign here means we need to distribute this sign to each one of these. Or in other words, change the sign of everything that's in this set of parentheses. So I'm going to make it a minus x and a minus 6, all equal to 18. Now see here, I think some people get into trouble because they start trying to move things around. Before you clean this up, you should combine like terms before you do anything else. So I've got 5x and negative 1, or just negative x. So that's 5 minus x, that's basically 4x. And negative 40 minus 6 more is negative 46, all equal to 18. See, if you do that, it makes it a much faster and much more clean solution. This would be plus 46. So we got 4x equals, well, 46. That is 50 plus another 14, 64. And then we'll divide by 4 to get x by itself, and we get x equals, if you had to, you could do it on a calculator, but I would say it is 16. Final answer. Let's look at number 24, which is supposed to be kind of the hardest one. So really, it isn't much different than the others. In fact, I think it might be a little bit easier, except that your final answer is maybe a little tricky to get. So let's distribute here. We're going to get 2x plus 8. And distribute here. The negative 5 gives me negative 5x. And negative 5 times negative 3 is positive 15. All equals 32. So again, I want to combine like terms over here. I got 2x and negative 5x. That's negative 3x. 8 and 15. That's positive 23. Equals 32. Now, simple subtracting of 23. Negative 3x equals 9. Now I divide by negative 3. X equals negative 3. All done. I think those aren't too bad. Some common mistakes would be up here in this one, forgetting to distribute the negative to both. Or here, maybe forgetting that the negative 5 is one thing and it gets distributed to both of those terms. Pretty common mistake. Okay, let's look at the next set. Some things put in here to kind of maybe trip you up. But again, really, if you keep with the principle of each of these problems, kind of the pattern for solving them, I think you'll find that you really start seeing the same thing over and over again. So here, I don't have any distributing, I don't have any like terms to combine. What I do have is n on both sides of this equation, and that's what I don't want. So I have a 3n here and a 1/2 n here. I notice a lot of people in class trying to multiply by 2 and so on. You can do that if you want, but it's really not necessary. If you just subtract the 1/2 n from both sides, that will cancel that away. You'll be left with 2.5 or 2.5 n minus 40 equals 35. And you see this really isn't too bad. You add 40, 2.5 n equals 75. And the last step, divide by 2.5. That makes n equals 30. Okay, number 29 has a little bit of distributing, a little bit of combining like terms. Let's distribute the 5. 5x minus 20 minus 1 equals negative 7x plus 3. We also have like terms to combine right here, so 5x minus 21 equals negative 7x plus 3. Here we have x's on both sides of the equation. You really don't want that, so you want to add these 7x away. That'll help get rid of the negative. We have 12x minus 21 equals 3. Now I'm going to add the 21 so that I get the x term by itself. 12x equals 24. And then just divide by 12. We get x equals 2. This time, I see distributing here, nothing here really. So we have 12x plus 20 equals distributing 6x plus 24. Okay, I can get rid of this 6x. We have variables on only one side instead of two. I subtract the 20 away now, so that I have just a variable term now. And I divide by 6, so that I can get just the variable. So here I have 4 over 6. If you put on a calculator, you're going to get a decimal anyway. So let's just reduce the fraction and be done with it. 2 goes into both, 2 on the top and 3 on the bottom. Final answer. I think we're starting to get into some that are maybe a little harder here, but I think if you keep in mind that the principle is always the same, it shouldn't be too bad. So let's see, what do I got in this problem? I have a little bit of combined like terms here, and nothing over here yet. So let's combine these two like terms together. 8t and negative 6, that's 2t plus 11 equals 5t plus 35. It doesn't matter, but I would say let's subtract the 2t. That way we'll keep out of negatives. 11 equals 3t plus 35. And I guess we're going to get negatives anyway because we're going to subtract 35 away from both sides. This will be negative 24 equals 3t. And when I divide by 3 on both sides, I get negative 8 equals t. It doesn't matter if the variable ends up on the right side or on the left side. In geometry, when you did proofs, you would learn that that's called a reflexive property. Okay, I think number 32 is probably one of the toughest ones that you have to deal with here. When I did this for you in class, I told you to show that this problem is actually equal on both sides. It's called an identity. What it means is that you're not really going to solve for x. You're going to prove that this equation just happens to be true. So I'm going to distribute over here. I have 2x, and now distributing plus 4x plus 4 equals, and now I'm going to distribute over here. 6x, that's not too bad. But how do I do 6 times 2/3? Well, it's a pretty simple thing. You multiply the top number and then divide by the bottom. So I have 6 times 2, that's 12. Divide by 3 gives me 4. If I combine like terms here, 6x plus 4 equals 6x plus 4. Do you see how I have the same thing on each side? Exactly the same means that it's an identity. There's nothing else to solve. If I subtracted 6x away from both sides, I would get 4 equals 4. Which is true, but there's nothing to solve. This time, I asked you to prove that this one is not equal. So again, let's do some distributing over here. So we'll leave this alone. Leave this alone. I got 4 times 4, that's 16. And I got 4 times 2x, that's 8x. Okay, if I combine like terms on that right side now, the negative 8 and the positive 8 will cancel and I get 8 equals 16. But that's obviously not true. So I've just proven that this was not really an equation at all. Those two things were not equal. Okay, this time we have some inequalities. Because we talked about in class, the only difference between an inequality and an equation is that maybe in that last step, you might have to reverse the inequality symbol. But as far as solving is concerned, you do it basically the same way. This one's about as simple as they come. We'll just subtract 8. And we get negative 3x less than or equal to 6. Here we are dividing by negative 3 in this last step. When we divide by negative, that means we have to flip this symbol around. Like that. And we get negative 2 over here. So it's this step right here, to divide by a negative, that made us flip that around. You do have to graph this on a number line, but I don't require you to make a really complicated number line. I put a 0 here, put a negative 2 here. The line on it underneath of that means that you're going to put a closed circle on negative 2. And since the x is on this side, it's telling us x is greater than negative 2. Where's the stuff greater than negative 2? This way. So you're going to shade this direction. You could also look at it as the arrow points the direction you're supposed to shade. Okay, this time we have an inequality that just has some distributing on both sides. So let's do that. 3 times x and 3 times negative 1. Keep the symbol the same. 7x and 21. For inequality purposes, I would suggest keeping the x on the left side if possible. Even if it would be a little bit more inconvenient, it's probably better for when you graph it. It'll help you avoid making mistakes with it. To subtract 7x, we'll get negative 4x minus 3 greater than 21. I'm going to add 3. Notice that I've kept that inequality symbol the same way the whole time. Okay, until right here when I divide by a negative 4. When I do that, I get x. Now I'm going to reverse that, less than negative 6. And I need a number line. So I put my 0, and I put a negative 6 over here. This time, I have no line here, so I'm going to leave this as an open circle. And then I'm going to shade this way, where all the things that are negative 6 are located. All right, last of the inequalities. Distributing on both sides, probably some combining of like terms. 5x minus 10, 8x plus 24, and then this plus 2 comes down. So just a little combining like terms here. All right, again, it would probably be convenient to take the x to the right side. You'll avoid a negative. But, you know, for purposes of graphing the number line, it's probably easier to keep the x on the left. So I'm going to take minus 8 from both sides. That's going to leave me negative 3x minus 10 greater than or equal to 26. I'm going to add this 10 away. Negative 3x greater than or equal to 36. Now I'm going to divide by negative 3. So here again, another time when we have to flip the symbol. Dividing by a negative makes us reverse this, and we're going to get negative 12. So for a number line solution, one last time, we put a 0 on here, and I put a negative 12. It has a line underneath of it that represents equal to. That means a closed circle. And then less than negative 12 is this direction. There's all the stuff less than negative 12, this way. All right, we have two word problems for you. They're a little bit different, but they're linear expressions nonetheless, so they're all a little the same, too. So number 40 is a very common way of determining a pay. So it says that Pat is paid a salary of $500 a month. $500 a month or per month, and a commission of 15% of the value of jewelry she sells. So basically, she gets a flat rate of $500 per month as sort of like guaranteed pay. And then she gets 15% of all the jewelry she sells. So she's paid on what's called commission. So find the value of jewelry that Pat must sell in a month to earn at least $2,000. So what I asked you to do is to write an expression for how much money she earned. So basically what you're saying is, okay, she's going to get P equals her total pay is equal to 500 per month. So you multiply that by the number of months, 500 per month. And then she also gets 15%. Well, we never write 15%. We write it as a decimal. So she's going to get plus, she gets her 500 a month, plus she gets 15% or 0.15 of the jewelry that she sells. We don't know that jewelry right now, so we'll put a J in there for jewelry. So you see I got a couple of different variables going on in here. What I would want to know for how much total money she makes is how many months she's been working and how much jewelry she sold. Those are the two things that determine her pay. How many months did she work, and how much jewelry did she sell, so she can figure out her commission. So in this case, it says, find the value of the jewelry Pat must sell. So find the jewelry. So this is the expression right here that we've come up with. But what we want in this problem, for the answer for the problem, is to find the jewelry, to find J, if she wants to make for 1 month, so M equals 1 month, and she wants to make a total of $2,000. So what we've really been told is that T equals 2,000, that M equals 1, and then the jewelry is what we're looking for, this variable. So what we really get is 2,000 equals 500 plus 0.15J. Okay, well, then to solve this, I've got to subtract off the 500. That gives me 1,500 equals 0.15J. And to get J, I'm just going to divide both sides by 0.15. And that happens, I get J equals 10,000. So if she wants to make $2,000 in a month, then she needs to sell at least $10,000 worth of jewelry. See, what's nice is because you're doing an inequality, it doesn't have to mean she has to sell exactly 10,000. I'm sure she could want to sell more. So you could actually say that she needs to sell greater than or equal to $10,000. It's a very practical, real-life situation. Number 42 says, In 2004, there were 3 wide receivers for the Indianapolis Colts that caught a total of 37 touchdown passes. Reggie Wayne caught 2 more than Brandon Stokely, and Marvin Harrison 3 more than Reggie Wayne. How many touchdown passes did each catch? Okay, I didn't ask you to write an expression for this one, but I think it wouldn't be too bad if you tried to do that. Let's just say that Reggie Wayne is X. Okay? What are we going to say about Marvin Harrison? That's easier. Marvin Harrison caught 3 more than Reggie Wayne. So if Reggie Wayne is X, how do you say 3 more than Reggie Wayne? Well, we say 3 plus X or X plus 3. Right? So Marvin Harrison is Reggie Wayne plus 3 more. X plus 3. What about Brandon Stokely? It says Reggie Wayne caught 2 more than Brandon Stokely. So if Reggie Wayne is X and he's 2 more than Brandon Stokely, what that means is Brandon Stokely is like taking Reggie Wayne and just saying, well, 2 less. Brandon Stokely caught 2 less than Reggie Wayne. So if Reggie Wayne is X, Brandon Stokely must be X minus 2. So what we have is this many touchdowns, and this many touchdowns, and this many touchdowns, added up should give us 37. So we have an expression to work with here. Right, that all 3 guys added up gives you 37. Let's combine the x terms into 3x and the regular numbers into positive 1. I'm going to subtract 1, and I'm going to divide by 3. So I get x equals 12. So we come over here on the side, Reggie Wayne was just equal to x. So Reggie Wayne must have caught 12 touchdown passes. Brandon Stokely, he was x minus 2, so that means 12 minus 2. He must have caught 10. And Marvin Harrison, he was x plus 3. 12 plus 3, he caught 15. If you look at it, these 3 numbers add up to the 37 total touchdowns. I would anticipate something like number 40, or somehow writing an expression for a paragraph being a bonus question.